What's going on, friends? In this video, I will break down all you need to know about functions in Python. Up until now, we've used functions like print and input to display text and collect information from a user. These functions are called built-in functions because they are defined in Python by default, making them available for use. A function performs a specific task, such as calculating the length of items in a list. One of the benefits of functions is that they are reusable. For example, you can call the print function as many times as needed. Stick around until the end, as we are not just learning but also applying our knowledge by building a practical Python project that takes all the scores of a student and determines the grade. Alright friends, the first thing we want to do is to write our own custom functions. This is known as function definition. Once we've created our own functions, we will move on to using them, a step commonly referred to as calling a function. Next up, we will explore the distinction between function parameters and arguments. We will also touch upon optional parameters, the return keyword, the pass keyword, docstrings, and finally, to solidify our understanding, we are going to complete a project exercise. Without further delay, let's get started. To create a function, we use the def keyword, followed by the function name, parentheses, and a colon. The inner part of the code is the function body. The function body is the indented block of code below the function name. It contains statements, logic, and the functionality that you want the function to perform. Let's create our very first function that greets a user. We need to bring in the def keyword, def, then the function name, greet, parentheses, a colon. Then we press enter. Print, welcome. Print, how are you? All the instructions needed for a function to perform its task are enclosed within the function body. Now we've been able to define a function, and the next step is to make use of this function. To use a function, we need to call it by its name. The name of the function is greet. We just need to mention the name of the function, which is greet, followed by parentheses. That's all. When we call a function, the function body is automatically executed. The body represents what the function does. Let's run the program and see the output. Great, welcome, how are you? As you can see on the terminal, the function body is automatically executed when the function is called. One advantage of defining a function is that we can call it any number of times. For instance, we can decide to call this greet function again. We just need to call it again. I'm going to bring up the terminal. So now let's execute the program again. Great, the function body was executed twice because we called the function twice. This is similar to how we've been using the built-in print function. Print. As you can see, they look similar. The only difference is that Python has defined the print function, so we just need to use it without declaring it. One point to keep in mind is that a function must be defined before it is called. Function definition comes before function call. We are able to make use of this greet function because we have defined it up here. Now let's reverse the approach whereby a function call comes before a function definition. The code editor is already showing us a warning before we run the program. Greet is not defined. If we run this program, Python is going to throw an error because a function definition must come before a function call. Now let's run the program and see the output. Name error. Name greet is not defined on line 5, which is this line of code. To make this to work, we need to bring down the function call below the function definition. Whenever you define a function, you are allowed to put a placeholder that would be passed when the function is called. The placeholder you put in between parentheses are called parameters, and you can actually make use of those parameters in the function body. As you can see, the greet function is now customized to say the name of the person. The actual values sent or passed when we call the function are called arguments. Let's write a function that calculates the sum of two numbers. Let's define the function def. The name of the function should be descriptive enough, sum underscore numbers. The first parameter should be n1, which is the first number. The second parameter should be n2, which is the second number. The body of the function result, which is a variable, equals n1 plus n2. Point sum of the two numbers is result. We've been able to define a function which is sum underscore numbers. It requires two parameters, n1 and n2. In the body of the function, we summed the two parameters n1 and n2. After that, we print out the result to the terminal. Now it is time to call the function. We just need to say sum underscore numbers, which is the name of the function. Then we pass in the arguments. This function requires two arguments. As you can see, the code editor says add two missing arguments. Sum underscore numbers expects two positional arguments. So let's pass the actual values 10, 40. This is how we are going to call the function. The name of the function followed by parentheses. Then we pass in any arguments that is required. Let's run the program and see the output. Sum of the two numbers is 50. Let's try it out again. 50. Let's run the program again and see the output. Great. Sum of the two numbers is 90. This is one of the benefits of writing a function. You can use it as many times as needed to perform a specific task. For instance, this sum number is only adding two numbers together and giving us the results. The greet function takes two parameters, name and age. As a result, two arguments must be passed when the function is called. Arguments passed as comma-separated values are called positional arguments. This means the first argument maps to the first parameter, the second argument to the second parameter, and so on. Now let's change the order to see what happens. Let's execute the program again. Your name is 10 and your age is Ali. The function may even still work, but it is very unlikely to produce the correct results. This is because we are using positional arguments, meaning the first argument is mapping to the first parameter and the second argument is mapping to the second parameter. In this case, this 10 is referring to name and this Ali is referring to the age. This is where keyword arguments come in handy. We don't need to worry about the order of the passed arguments. When you are calling a function, you can specify arguments in the form of age equals 10, name equals Ali. Arguments specified in this format are called keyword arguments. It means you have to specify the name of the parameter and the value, the name of the parameter and the value. Each keyword must match a parameter in the function definition. This is a keyword, which is age. It is mapping to age in the function definition. This is another keyword, which is name. It's matching a parameter in the function definition. Now let's run the program again and see the output. Great, your name is Ali and your age is 10. The program still works fine if we change the order, because the order does not really matter. Let's run the program again and see the output. Your name is Ali and your age is 10. Using a keyword that is not present as function parameter throws an error. Let's try that out. Let's pass in a keyword that is not present. Level equals 5. The code editor shows a warning before we even run the program. Remove these unexpected named arguments. Level should not be included because it is not present as a parameter in the function definition. Let's run the program and see the output. Type error. Greet function got an unexpected keyword argument level. You should also remember that the number of arguments must be equal to the number of the parameters. We are also allowed to mix positional argument and keyword argument in a single function call. Let's remove this keyword argument, making it positional argument. This string is positional argument while this one is keyword argument. This maps to the first, while age, which is keyword argument, maps to the age in the parameter. All positional arguments must come before keyword arguments. So let's run the program and see the output. Great, your name is Ali and your age is 10. Let's change the order by writing this way. This is not going to work. The rule is that positional arguments must come before keyword arguments. Let's run the program and see the output. Syntax error. Positional argument follows keyword arguments. In Python, if you set a value like this in function definition, it becomes the default for that parameter. This is called default or optional parameter. It means if you don't provide a value when calling the function, it uses the default one you set. If we move on to call this function without specifying the age, it is going to rely on this default one, which is 10. This is a mistake. Age is meant to be an integer. If we call this function without providing the age, it is going to work because we have provided a default value. Let's run the program and see the output. Great, your name is Ali and your age is 10. Now let's provide a value for the age, 20. In this case, it is not going to rely on the default value. Your name is Ali and your age is 20. We can also provide a default value for name. In that case, I can decide to remove the arguments passed. Let's run the program and see the output. This function call works because we have default values. The return keyword is an optional statement in the body of a function. If we want our function to return some values to a function call, we use the return statement. Let's use one of the previous examples. When a function is called, all the code in the function body is executed. If a return statement is encountered inside the function body, the execution stops and the control of the program is returned to the caller. Let's modify this function to return a value, which is the result. Return result. Let's call this function sum numbers 5, 4. X equals sum numbers. This function has been designed to return a value. When the function is called, a value is returned back to us. That value is now what we save in this new variable x. Let's give the variable a better name, summation. We can now move on to use the variable however we want. Print sum of numbers is summation. Let's run the program and see the output. Great, sum of the numbers is 9. A return statement in a Python function serves two purposes. First, it terminates the function and passes execution control back to the caller. It also lets the function send data back to the caller. The data returned or sent by the function is saved in this new variable. The pass statement is a statement which can be used as a placeholder for future code. For instance, if you declare a function without the function body, Python receives a syntax error stating that you must provide a body. Let's declare a function without a body, add numbers. So if we try to actually run the program, Python is going to throw an error because you must provide the function body. But sometimes we just want to come back to this part of the code. In that case, we can use pass. Let's run the program again. The pass statement does not really do anything. It only prevents Python from throwing a syntax error. We can also make use of pass in if statements. Let's say if 5 is greater than 6. Let's run this program and see what happens. It shows an error that the inner block of code cannot be empty. We can simply use pass. This block of code is going to run fine now. Great. Docstrings are string literals that appear right after the definition of a function, method, class, or module. A function docstring is like a note that explains what the function does, its arguments, its return value, and any other helpful details. We can access the documentation of a function by using the doc attribute. We just need to say function name dot double underscore docs. Let's print this out to the terminal. Print. Now let's execute the program. Great. Built-in functions also have docstring. Let's try that out. Print, which is the built-in function, dot docs. So now let's execute the program and see the output. Great. As you can see, it is showing us the parameters that can be passed to the print function. Value, print the values to a string. The docstring does not always need to be a single line. You can use multiple lines if needed. Let's take a look at this example. This function calculates the area of a rectangle. As you can see, we have the parameters mentioned in the documentation as well as the return values. Alright friends, the task is to create a project that takes student scores and computes the corresponding grades. The first thing we need to do is to create a function that calculates average score. We also need another function that determines the grade. Let's create the first function that calculates the average score. Def calculate average scores. This function takes scores as the parameter. The score is a list of numbers, then the body of the function. If not scores, that is when the score is an empty list, we want to return 0.0. Be sure to check out the lesson on if statements for a more detailed explanation on when a variable evaluates to false. We want to define a new variable total equals sum, which is a built-in function, scores. The sum built-in function is going to sum all the scores together, that is all the numbers. Then we want to define a new variable average equals total divided by the length function returns the length or the number of items in a list. And finally, we need to return the average score. This function is going to take a list of numbers as scores and compute the average. This part of the code is needed because if the list is an empty list, the length of the list would be 0 and any division by 0 is going to raise an error. Let's move on to define the second function. This function determines the grade given an average score. The function name is determine grade. Then we pass in the parameter. The parameter needed is the average score. If average score is greater than or equal to 90, then this part of the code should be executed. We want to return string A, which is the grade. If average score is greater than or equal to 80, return B, which is the grade. If average score is greater than or equal to 70, return C. If average score is greater than or equal to 60, return D. Else, if none of the conditions is true, return F as the grade. The first function is to calculate the average score, and the second function, which is determine grade, is to compute the grade based on the average score. Let's make use of the two functions. Average score value which is a new variable equals calculates average. Then we pass in a list of numbers 1, 2, 6. Let's declare a new variable called grade value equals determine grade. Then we pass in the average score value. Alright, on this line we are computing the average score by making use of the calculate average function. The calculate average function returns a value, and the value returned is saved in this new variable. On this line we are computing the grade. We are passing the average score as an argument to this function, which is the determine grade. This determine grade returns the grade. So now let's print out the grade value. Print grade is grade value. Let's execute the program and see what happens. Great, your grade is F. Let's use 90, 80. Hopefully the grade should be B or A. Great, your grade is B. Let's pass an empty list as the argument and see what happens. Your grade is F. Now let me show you the purpose of this part of the code, if the list is empty or not. Let's run the program and see what happens. 0 division error, division by 0. Remember, when the list is an empty list, the length of scores is going to be 0. So the total divided by 0 is going to raise a division by 0 error. Here are some questions you can try on your own. Write a function that takes a list of numbers as parameter and returns the highest value. Write a function named isEven to determine whether a given number is even. Create a function named Celsius to Fahrenheit that converts a temperature from Celsius to Fahrenheit. Create a function called isPalindrome that checks if a given string is palindrome. I hope you enjoyed the video. Feel free to let me know in the comments if you have any questions. Please like and subscribe to the channel. Thanks for watching and see you in the next video.